everyone, welcome to a really cool episode of BioLogic Science News. Today I want to talk about a spectacular medical success story, and one of numerous studies that came out of this case about the plasticity of the human brain. The patient in this medical success story is Zion Harvey, a little American boy who, as a toddler, contracted a dangerous infection. To save his life from the progressing disease, Zion had to have both of his hands and both of his feet amputated. It was an extreme solution to an extreme infection, but it saved his life. Years later, Zion would become the first recipient of a double hand transplant, undergoing the novel surgery when he was just 8 years old. The procedure was extremely intense, as the surgeons had to connect the bones and the vasculature of Zion's arms with those in the transplanted hands, and they also had to connect the muscles and the tendons, and most challengingly, the nerves that would allow Zion to move his hands and use his fingers to feel sensations like temperature and texture. Due to the magnitude of the transplant, Zion will have to take immunosuppressant drugs for the rest of his life to protect him from the risk of infection and transplant rejection. He has to be carefully monitored. He'll have to go through physical therapy to develop dexterity and coordination in his new hands. It won't be easy, but it's a whole world apart from where he was years before, with no hands at all. Follow-up interviews and medical assessments with Zion show that his recovery has been exceptionally fast. Within just a couple years, he's not just able to feed himself and dress himself and go to the bathroom, he can also write with a pen, swing a baseball bat, climb on monkey bars, and play video games. This success story is amazing for multiple reasons. The patient's story has elements of both horrible tragedy and unbelievable recovery. The medical procedure itself is amazing. It's never been done before, and it worked. And Zion himself is a charismatic, enthusiastic child who couldn't be more deserving of such an incredible procedure. Another great thing about this case is that it's provided a veritable treasure trove of medical data on everything from general transplant medicine to surgery to neural remapping. That last bit about neural remapping is what I want to talk about today. Researchers saw that Zion's brain had undergone major, rapid restructuring in response to his hands being amputated, and in response to new hands being transplanted onto his body. This brain remapping is called MCR, or massive cortical reorganization. When this occurs, the structures in the brain that receive feedback and send signals to particular body parts are physically rearranged so as to accommodate a neural system that isn't receiving input from an amputated body part. William Getz, PhD, was an author of this remapping study about Zion's brain. With regards to MCR, he said, quote, "We know from research in non-human primates and from brain imaging studies in adult patients that following amputation, the brain remaps itself when it no longer receives input from the hands. The brain area representing sensations from the lips shifts as much as 2 centimeters to the area formerly representing the hands." Unquote. About Zion's case specifically, he said, quote, "We had hoped to see MCR in our patient, and indeed we were the first to observe MCR in a child. We were even more excited to observe what happened next, when the patient's new hands started to recover function. For our patient, we found that the process is reversible." Unquote. What this means is that Zion's brain experienced remapping when his hands were first amputated. This was in response to his altered neural architecture and the subsequent loss of any sensory input coming in from his hands. His brain structure literally changed so that the parts associated with his hands atrophied and made room for other sensory processing regions, which presumably became more sensitive. Then, after the transplant had reconnected a pair of hands back into his neural architecture, Zion's brain remapped again, but this time it reverted back, closer to the original state of a healthy human body that had experienced no amputations at all. Another author of the paper was L. Scott Levin, MD, who led the transplant surgery performed on Zion. Mr. Levin was quoted as saying, "Zion has been a child of many firsts here at Penn Medicine and Children's Hospital of Philadelphia and across the world. With the changes observed in his brain, which our collaborative team has been closely evaluating since his transplant 2 years ago, Zion is now the first child to exhibit brain mapping reorientation. This is a tremendous milestone, not only for our team and our research, but for Zion himself. It is yet another marker of his amazing progress and continued advancement with his new limbs." Unquote. This study is really important because it helps us learn how better to integrate transplants into the host body. It gives us a look into massive cortical reorganization as a biological phenomenon, and at brain plasticity in children in general. With this knowledge, we can better understand how and when to conduct transplants, so as to maximize healthy integration into the host body. This is good news for those who've lost or are missing a limb, and have long desired a viable surgical solution.